Yeah, good day everyone. So this this is a video just to explain the physics practical that will be coming up next week Monday, and we just have a setup that we can use based on what the apparatus that we have provided or that we're instructed to be given to be provided to the students from WAEC. So number one, we have the 2 liter stand. These are the 2 liter stand in the diagram. You'll see it this way, and we have the clamps. These are the clamps with the bushhead, and also we have a thread. Thread should be provided, and that's the thread we use to guide to join these two spiral spring coming. Let's need to shift this a bit. So now we also have the meter rule. A meter rule, we have masses 150, 200, and so we have these masses. These are 100 grams, and we have 50 grams. So this is 100 grams with the hanger, but I'm not going to use this. We are provided with 2 liter stand with clamps, 2 identical springs, a spiral spring, a meter rule, a set of masses, a stopwatch, and other necessary apparatus. Set up the 2 liter stand parallel to each other. This we have done already. Suspend 1 spiral spring from each stand. You can see from this setup we have the spiral spring suspended from this liter stand, and the other spiral spring suspended from this liter stand. Okay. Use a small piece of thread to connect the lower loop of the 2 springs horizontally, and suspend a mass hanger from the midpoint of the thread. So I am going to use this small thread. I'm using this small thread to connect the 2. You need to tie it very well so that while you are performing your experiment, the thread will not lose. So I think this is okay. We can cut that later. Also, after doing this, attach the optical pin horizontally. This is the optical pin. I have attached it horizontally to the mass hanger using a small piece of plasticine. So I use a rubber tape or a black tape to hold it firmly to the base of the hanger. Now, so this is serving as a pointer to the meter rod that has been clamped. So it's serving as a pointer against the vertically clamped meter rod. So we are to suspend this at the midpoint. So from here, read and record the initial positions of the pointer on the meter rule when the system is unloaded. So that is when M is what? So on the table, when M is unloaded, M equals to 0. We have not loaded any mass on it. The initial reading of the pointer, we can see. So you look at it closely. Don't touch the return stand. So this is giving us 53.1. So the value of our S naught is 53.1 centimeters. Now note, when you are making readings in physics, immediately you try as much as possible to record it to at least 1 decimal place for measurements recorded with meter rule. So I can even write 53.10. It's still correct, but the centimeter must be there. So this is our value of S naught. Now the instruction, let's now start with the other instructions that we are given here. Okay, read and record the initial positions of the pointer on the meter rule when the system is unloaded. This is your reference point S0. Place a mass M equals to 150. So in this case, I'm going to 150 is a sum of 100 grams and 50. So what I'm going to have, what I'm going to put the 100 gram mass and also add my 150 gram, 50 gram mass. From this, I am having, so we have to record the new position of the pointer X. In this case, we can now draw our table of values. So table of observation. So serial number, these are the iterations we are having. The first thing we are having here is the values of our masses. So masses in grams. So I'm going to write 50. I always advise students, just record everything to 2 decimal places, so you don't have to disturb yourself about did I get it right? Did I get the decimal points right? So 150.00. I think the next one, sorry, I need to check my phone here. I hope you can see me. The next one is 200.00, 250.00. We have a 300.00. We have 350.00. Then we have to record. This is our reference point S0. We have to record the point X. And if you are going to record X, the unit must be stated in centimeters. So we'll do this. So in this case, we have this is 61.6. So 61.60. And calculate the extension E. The extension E equals to X minus X0 in centimeters. So we are going to take, please, I need the calculator. 61.6 from minus 53.1. What's the answer? 8.5. So we have 8.50 in this case. So displace the mass slightly downwards and release it so that it executes vertical oscillation. So we are taking 2 times T1 in seconds, T2 in seconds, and we are told to also look for the T average in seconds. We have to find the period in seconds and also the square of the period, second squared. When writing this, you are not to break this table, else your table of composite table, you will lose the mark for table or composite table. So let's go on. I need the stopwatch now. So this is my stopwatch. It's already set to 0.0. So now we need to take it down a bit and record. Okay, so you displace it a bit downwards. Coming. This needs to be at the center. Okay. So we are suspending the lead a bit downward, then we start. 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm going to take that. This gives me 14 seconds, 14.28 seconds. So we can take it again. You can take the value again. So you reset your stopwatch and you also do it again. Let's take it. 1, 2, 3, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 1. So we are going to displace it now and put your hand on the stop and start button. So we have what? 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we also have 14.12. 14.12. So you can see the reading here. This is the reading, 14.12 seconds. So we can, I'll just, for the purpose of time, because of time, I'll just do just one of the time. And let's take, the next question says we should find 200. So I can remove this 50 gram and add my 100 grams to it to make it 200. So we need to read. You should be able to remove this phone and read this. Remove the phone. Yes. Remove it from it. Okay. So let's look at the reading. The reading says, so let this rest. So we have 65.0. So we have 65.0 for this. So what's the extension? We can calculate the extension. Let's quickly take the time for this. So we take it 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 15.85, 15.87, sorry. 15.87. I'm only taking one of the time. Well, we can redo that too. Let's do the second one. Okay, let's take it again. 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 15.4. 15.44. Okay, so let's remove this. We have to calculate, okay, 250 is the next one, so we don't need to remove the 100, just add your 50 to it. Add your 50 gram mass to it. So let's look at where the pointer is now. We are having the pointer at 68. So you need this thing to balance well. 68.5. 68.5. Okay, so let's take the time. The period of the time for oxidation now. So reset your time and let's go. 1, 2. So you displace it just a little. You don't need to stress from the point, just take it a little down. 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is time 17.53. So we have 17.53. So let's take it again. One, two, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 17.75. Let's take the next one. The next reading is 300. So we remove the 150 grammars from it, and we add another 100 grammars. So simple, just for you to add. And so you have to be careful so this does not affect your reading. Don't drag the prior spring. Coming. So that's 300. So let it be settled. And it's settling around, this is settling around 72. That's 72. So we have 72.0. No, 70.2. That should be 72.2. 72.20. Okay, so we can now take the oscillations now. Are we ready? So 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 18.97. 18.97. Let's take the second one again. 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 19.12. So we can, I think the last one now is to take 350. So you add your 50 grammars there and you read the pointer. So let it settle. And this is 75.5. 75.50. So let's take the reading for this. Okay, let's take 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. This is 20.31. 20.31. So let's take it again. Okay. 20.31. 1, 2, ready, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20.66. 20.66. Yes, you can see that there is variance in the time T1 and T2 based on the amount of displacement I gave it. So at some point I did like maybe it is. So that's why you have the varying time. Now let's take what's the extension here, please. Okay, so 65 minus 53.1. 55 minus 63.1 is what?
11.90.
So I think we can remove this. What do you say?
11.90.
11.90. Yes. Next one.
15.4.
What?
15.4.
15.40. Yes.
What's that?
That's 72.20
Minus 53.10.
19.10.
19.10. Okay. 75.5 minus 53.1.
22.40.
20.40. So let's take our T average. So you add this and divide it by 2.
14.20.
14.20. What is 15.857 plus 15.44 divided by 2?
15.66.
15.66. 17.53 plus 17.75.
17.64.
17.64. Yes. 18.97 plus 19.12 divided by 2.
19.05.
19.05, right?
Yes.
Okay. 20.31 plus 20.66.
20.49.
20.49. Then T, how do we get the value of T? T actually equals to T divided by the 20. So the time you have calculated here and you add 20 exhalations. So you are going to divide it by 20. So what is T, this T here? 14.20 divided by 20.
0.71.
0.71, yes. 15.66 divided by 20.
0.78.
0.78. 17. 0.88. 19.05. 0.95. 20.49 divided by 20. 1.02. So let's square them. 0.71 squared will give us 0.50. 0.78 squared 0.61. 0.88 squared 0.77. Are you squaring them? This times this, the same thing. Okay, 0.95 all squared 0.90. Then 1.02 1.04. So this is our table of value that we have just got from this experiment. So the next thing is to check the, so you have to tabulate your M. Now if I think the M was written as a capital letter, you have to take note of that. If it is written as capital letter, do not write it as small letter. So capital letter. So for having this all in a straight line, so if you have a very big handwriting, you have to manage yourself. You have to look at how you're going to manage your space and make sure everything is on a table. Don't break the table. Oh, maybe I've drawn this to this place and there's no more space. You bring this other 4 down. You have already lost mark for composite table that way. So the next thing is to draw a graph. So drawing a graph of maybe E against T square or T square against E or M against T square. So that is what the question might ask you to do. And I believe that graphing is not supposed to be a problem to us. I think I'll continue in the next video. Okay, so we want to try and plot a graph of t squared on the vertical axis. So t squared, the square on the vertical axis against our m, the mass of the values that we have here. These are 0.0, we have 50, we have 100, we have 150, we have 200, we have 250, we have 300, and we have 350. For your most states, the mass in gram. So for distinguishing this, you have 1 mark out of 6 marks on the graph. Now we are to set this 0.50 to 1.04. So we need to look for a very convenient way of representing this. That we will have, let's see, 1.04 is the highest number, and we have how many points here? 1, 2, 3. On your graph, you always have 12 boxes, so you can divide it, or if you look at it, you can look for the best way of representing it. So let's say if we have 0.1, 2, 3, 4, 5, 6, 7, 8, it won't reach. So we can say this 0.2, 0.4, 0.6. 0.8, 1.0, and 1.2. I think this has covered everything that we need to do. So that means that each of these boxes, we have 10 boxes here, each of these boxes actually stand for. So you just say the lowest point here, 0 to 0.2 is 0.2. So if you minus this difference, you have 0.2 divided by 10, that's 0.02. So each of these boxes are 0.02, 0.04, 0.06, 0.08, 1.00, 0.10, I mean, then 0.12, until you get to what? 0.2. So from here, we have actually distinguished our graphs. The axis distinguished, and the scale also stated. Yes, physics practical does not require you to write, on y-axis represent 1 centimeter to represent so units on the mg graph. No, you just need to state that this is t squared and m, then this is your scale. This is what you mark. Now from here we can now start taking our points. Yes, 150, when m is 150, our t squared is 0.5. So 0.5 is here, this is 150. So we are going to mark the center here. Then when it is 200, it is 0.61. This is 0.7. This is 0.062. So 0.61 should be in between the 0.6 and 0.62. Are you following? So I am using cross to identify my points. The point that I'm matching. Okay, I have 0.77 against 250. This is 250 here. 0.77. This is 0.7, 0.72, 0.74, 0.76, 0.77 is right here. I also have 0.90. 0.90 against 300. 90 is here. And 1.04. This is 1.0. This is 1.02. This is 1.04. So, because someone will say 1.04, what? It's still 1.0. Don't put it here. No. You have to read it as against 3. That's 1.04. And that's why you need to know the division of each of the boxes. So once you know the division of each of the boxes and you get your long ruler, a very long ruler, so you have to get that. Let's see. Can we have a straight line? This, I can pick 2 points here, but I will not be able to get my line of best fit because 3 points are outside at one side of this. So let's see if I pick these 2 points. If I pick this, I think this is a good one. Yeah. Let me see. Let's see very well. That's why you need a transparent Okay, I think I can pick this. From here, let me see if I have a red marker here, a green marker. You can see from here, this is a point that is not matching with the point we have here. This one is not also matching with the line. So with this, we have the lines, the points are evenly distributed. For this, if I'm going to be graded in your graph, you're going to be graded this way. You have graph. For graph, axis distinguished, you have this axis distinguished properly. You have t-squared, that's 1 mark, half mark here, half mark there. Your scale, you have half mark here, half mark here. Let's look at this. Someone was writing 0, 0.2, and mistakenly he jumped to 0.5 or 0.6. This becomes 0 here. So he has lost mark for scale here. So this is 1 mark here. We also have what? Point distinguished. For having all these points, so we mark this point correct. This point was it was properly plotted. This pointed, this plotted properly. You have each of them. For you to have gotten all, you have 3 marks here. And we also have what? The line of best fit, 1 mark. Everything totals up to 6 marks. Then you can be asked to draw a slope. For drawing a slope, to draw the slope, we can pick any point on the graph. You don't necessarily mean the point that you have matched. So you can pick this. And it must be a right-angled triangle. A right-angled triangle. Your line must be straight. A right-angled triangle. This is your t square 1, t1 squared. This is your t2 squared. This is your m2. This is your m1. So in this case, we can calculate our slope. The slope s. Our slope can be written as what? Change in the t squared over change in the m. And in this case, we have what? What do we have here? T2. This is T1. Sorry, this is T2. This is T1. This is T2. The one higher. T2 is actually, this is 1.1. And this is 1.1 to 1.14. So we have 1.14 minus 0.6 over 350, this is 400, minus, this is 150. Look at this. This is where you have to look very well. This is 150. There are 50 differences. Between 50 and 0 is 50. So there are 10 boxes there. Each of the boxes, how do we get it? You say 50 divided by 10 boxes. That means each of these boxes on the x-axis actually represents 5 grams. So you are reading this from here: 150, 150, this 160, 170, 1. So let's place it down because of some of you that are not seeing it well properly. This is 200. This should be. This is 160, 170, 180, 190. Between 180 and 190, you have 185. So you have to read it properly. So please, can you help me do the calculation? So do the summation of that. So we have 1.14 minus 0.6. What's the value? 1.14 minus 0.6. What's that?
0.54.
0.54 divided by 400 minus 185.
250.
What?
215.
215.
Yes.
So divide it. What's the answer?
0. What's the difference?
0.0 0.0025. 0.0025. That's 22.5 times 10 raised to the power minus.
Yes, this is our slope. So we have developed our slope here, and that's how to. From here, the remaining questions may be, find the inverse of the slope or whatever. You can see the unit here as second squared. Well, if I was going to do my own, I might have even plotted my extension here. So it's possible that if we have plotted extension, if we plot extension against this t squared, we would have calculated, we may be able to calculate maybe the acceleration due to gravity here. Okay, so this is how to do this type of practical, and that is all for this